welcome back to lesson 4. We are now at part 5, and for part 5, we'll have some examples. So, in this video, we'll have example number 1. Okay, so for example number 1, graph the equation quantity of x minus 1 squared over 16 plus y squared over 9 equals 1. Okay, so by the way, maybe somebody will ask, why is it always 1? Okay, is it always 1? It's because it's the standard form. Okay, so if the number here is not 1, you should divide that number, okay, in such a way that the number here will become 1. So for example, if this is 4, so divide it by 4. So the right hand side of the equation should always be 1. Okay, so let's go to the board for us to graph this equation. Okay, so this is our given here. So again, given is just x minus 1 quantity squared over 16 plus y squared over 9 equals 1. Okay, so step 1. So in solving, we need to get the values of a and b. Again, for step 1, we need to find a and b. Okay, so what is our a and where can we find a? Okay, so take note that a is always found in the constant, okay, denominator, constant denominator, which is greater or the bigger number. In this scenario, the bigger number is 16. Okay, so remember this is actually a squared. And if this is a squared, to get the value of a, we simply get the square root. So what will be the square root of a? A is just 4. Okay, so take the positive number when you get the square root. It's because we are dealing with lengths. So a is just 4. While b is the lesser number. So this is actually b squared. And remember, so we have b equals, so square root of 9 is just 3. Next step is to find c. Okay, so again, we need to find a, b, and c. So to find c, we use the formula, Pythagorean formula. So we have c equals square root of a squared is 16 minus b squared is 9. So 16 minus 9 is, yes, it's 7. So we have square root of 7. So our c is square root of 7. Okay, so this is our c. I'll just write c. C is square root of 7. Step 3 is to determine the orientation. So what is the orientation? Okay, so it's very easy to determine the orientation. We simply refer to the equation. So again, refer to a, and wherever is a with the largest number here is found, that will be the reference for our orientation. So in this scenario, 16 is the largest number or the biggest denominator. So, and it's under x minus 1. And remember, x minus 1 is just what? What is x again? X is the horizontal part. Okay, so if it's the horizontal part, so we are sure that the orientation, the position of the ellipse is horizontal. Okay. Then we can also find the, let's just say it's step 4. So it's very easy. How to find the center. So center. To find the center, we simply use h and k. So we have c. Our h is 1. Our k is a y squared. For y squared, k is 0. Okay, so y 0 because it's y minus 0. Okay, so I erase the board. I'll summarize this one and erase the board. Okay, so I'll be back for a while. for the next step, so we need to find the focus or the two foci. Okay, so before we find the foci, let's try to draw first. So I have a rough sketch. Okay, so remember that uh, our ellipse is horizontal. Okay, horizontal. So if we have our center here, let's say the center is sorry, uh, it's kind of wrong. Uh, Center is at 1 0, so 1 in x, then 0, so somewhere here, center is somewhere there. Okay, then our ellipse is this. Okay, so this is our ellipse. So where can we find the focus? Okay, so the focus will be at this part here. Okay, in the horizontal major axis. Okay, hence, if it's at the horizontal part, the movement will be horizontal. So remember that the center is HK. Okay, so this is the center. Okay, hence we are going to add and subtract C at the H part. Okay, because again, the movement is horizontal. It's going to the left and going to the right. If it's going to the left, it's minus. If it's going to the right, it's plus. Okay, so we can say that our focus 1 will be our H plus C, okay, and our focus number 2 is H minus C, K. And what is our H? So our H is actually 1. Our K is 0. So we can replace this one. Let's try to erase. So replacing H with 1. So this is 1. This is 1. And our K with 0. Again, 0. It's here. 0. Okay, so let's try to put it 0 here and 0. So what is C? So our C is this one here, square root of 7. So let's try to substitute 7 to our C. Okay, so this will be square root of 7. Okay, so this is square root of 7. Now, using our calculators, okay, so I'll try to show my calculator here. Where is it? Calculator. Okay, so for a while, I'll be back for a while. Okay, so here is my calculator. So we have 1 plus square root of 7. So just click SD. We have 3.645, or rounding off to 2 decimal places, we have what's that, 3.646. So we have F1, we have 3.64 65. Okay, 65. 3.650. So this will be our F1. Okay, this is the answer for the first focus. For the second focus, we have minus. So we simply type minus here. Okay, so equals, then SD or decimal, negative 1.65. Okay, so we have negative 1.65. So our F2 is negative 1.650. Okay, so this will be our second focus. Okay, so I'll just erase the board and summarize the focus, add to the summary. Now we have the two foci, so we can now go to the next element. So for the next element, we're going to find the length of the major axis and find its vertices. Okay, so how to go about it? So we must remember that the length of the major axis major axis. So I guess my major axis. Okay, so is equivalent to, correct, it's 2a. So again, a is the length of the semi-major axis. So if it's if semi is a, so if the half is a, it means that the entire length of the major axis is times 2. So 2 times a. So this will give us 2 times, so our a is 4. So it's 4, it's here, 4. Okay, it's here. So 2 times 4 is 8. Hence, that is our length. Okay, now, if we have the length, and if we have a, we can actually solve for the vertices. So, you must remember that V1, so again, we start with the center. So, the center is H and K. Okay, and the major axis is horizontal. Okay, the orientation, because the orientation is horizontal, so we are going to add. Okay, so what are we going to add? It's the variable a. So plus a to our horizontal part, because again, the major axis is horizontal. Okay, so meaning our first vertex, okay, is h plus a k. How about the second vertex? So the second vertex is actually h minus a. So again, there are 2 points that are actually opposite to one another. So we have h minus a and k. Okay, so using substitution, so we know that k is, okay, so I guess we write it here. K is 0. So basically put 0 there. 0. While our h plus a, okay, so let's start to erase. H plus a is, our h is 1. It's 1 here. Center is 1, 0. Plus our a is 4. So let's just change the color. So it's 4. So for vertex 2, still the same 4k, is 0. And for a, this is 4. 4. And our h is also 1. Okay. So this will give us 1 plus 4 is 5. Okay, so 1 plus 4 is 5. And we have 1 minus 4, which is negative 3. 1 minus 4 is negative 3. So these are our vertices. Okay, so if we have the vertices, we also need to find the co-vertices. So let's try to put it in our summary and erase the writings on the board. Okay, so next, the co-vertices. So the co-vertices can be found in the minor axis. So what is the length of the minor axis? So what is the length of minor axis? Minor axis. Okay, so if the major axis is 2a, and we know that the length of the semi-minor axis is b, hence we know this is 2b. Okay, and our b is, so using substitution, so 2 times b is 3. So it's here, it's 3. Okay, here, 3. We have 6. Okay. So again, b is from here, 9. Square root of 9 is 3. A is from here, 16. Square root of 16 is 4. Okay, so if you're wondering where does the value of A and B came from. Okay, then value of C is square root of 16 minus 9. Okay, then looking for V3 and V4. So these are co-vertices. So we have again H and K. So the question is where to add our B. So again, the movement of the minor axis is B. So where to add B? So just remind yourself that V3 and V4 is always the opposite of V1 and V2. So if you add in the horizontal part for V1 and V2, so for V3 and V4, we are going to add at the vertical part. So we have to add plus B at K. Okay, then let's do the substitution method. Okay, so H, erase H, and H is, again, refer to the center, H is 1. H is 1. And K is, erase K, erase. By the way, this is minus B. Sorry. If one is plus, the other one is minus. Okay, H is 0. So let's write 0. 0. 0. Okay, then B is 3. So erase B, erase. Okay, so B is 3. Okay, then we also erase this 1. Okay, so minus 3. Okay, so we have 0 plus 3, which is just simply 3, and 0 minus 3, which is just negative 3. So this is our co-vertices. Again, co-vertices with CO. Let's see. Okay, so we have V1, V2, V3, and V4. We have now the endpoints of the ellipse. Okay, let's erase again the board and put the answers in the summary. Okay, so we're almost done. Okay, so for the next element that we should know, we should consider the directrix or the directrices. So in this scenario, we have two directrix or directrices. Okay, plural for directrix, directrices. So since there are two directrices, there are two answers also. So where to base the directrices? So you always need to remember that directrices are always dependent on the axis. Okay, so in this scenario, we have our major axis. Okay, so major axis is horizontal. So the orientation is horizontal. Okay, so if it's horizontal, again, horizontal movement, we have X and H. So you will have X equals H. Okay, so plus, according to our formula, we have A squared over C. So do not forget that for the directrices, it's A squared over C. And we have X equals H minus A squared over C. Okay, so you can put sub 1 here, X sub 1 or X sub 2, but later na lang. Okay, so let's try to substitute now. Okay, so we can now substitute. Our H is 1. Okay, so H is 1. H is 1 here. A squared is, so A squared is this one, 16. Okay, 4 squared is 16. So erase A squared. Erase A squared. Okay, so we have 16. And we have our C. So according to our result here, C is square root of 7. Here, square root of 7. Okay, so square root of 7. Square root of 7. Square root of 7. And using our calculator, okay, here is our calculator. So we have 1 plus, okay, so using this here, the two boxes here, okay, so it's the fraction symbol in your calculator, just press it. Then we have 16, go down, then we have square root sign, 7. Okay, then just press SD. So we have 7.047, so this can be rounded off to 7.05. Okay, so let's write that. 7.05. 7.05. Okay, then for the other line, okay, other equation, so take note that our equations are lines. When you have a first degree equation just like this, x equals a constant, that is a line. Okay, so let's just edit here. Instead of plus, let's have minus. Uh, Click equal sign. S. So we have negative 0.05. Okay, negative 0.05. Negative 0.05. Negative, I forgot. What's that? Negative 5.05. Okay, so these are our directrices. So we have x sub 1 and x sub 2. Okay, so let's type it here. Let's erase the board again. For the last element, we need to solve for the endpoints of the lateral recta. So the endpoints of the lateral recta is important because it will help us guide in creating the rough sketch. Okay, so what are the lateral recta? So the lateral recta always passes through the focus. So we're going to use our focus here, or foci. And also, we must remember that the lateral recta is perpendicular to the major axis. Okay, so always take note that the lateral recta is always perpendicular to the major axis. So if our major axis is horizontal, this implies that the lateral recta are perpendicular to the major axis and hence vertical. So we're going to add to the vertical part of our foci. Okay, so let's try to divide the board. Dividing the board, we have for F1 and F2. Okay, so we have F1 and F2. The focus 1 focus. So for focus 1 is 3.65 and focus 2 is negative 1.65. Then 0. Okay, sorry, there's also 0 here, so it's a point. Okay, so since our lateral recta is vertical, we are going to add to our vertical part of the point, in other words, to 0. So what are we going to add? So take note that to get the endpoints, we simply add, where is it here? Add or subtract b squared. Okay, so I just write it here, b squared over a. Okay, so you need to remember this to get the endpoints of the lateral recta plus minus b squared over a. You try to look at the notes, your notes, you will see that it's b squared over a. Okay, so hence we're going to add b squared over a to 0. So let's try first f1. So it's plus minus, so there are two cases. So let's have f1. We have 3.650 plus, what is our b squared? B squared is 9. Okay, 9 over our a is just 4. Okay, so that is our f1. Now for f2, so f2, sorry, it should be red. F2. So we have negative 1.65. Then we have 0. Okay, then we have plus 9 over 4. Okay, so we have the plus part. Now the minus part is just the same. We just rewrite it. We have f2, 3.65. Then we have 0. So instead of plus, just write minus 9 over 4. And same goes with the second focus. So we have negative 1.65. Okay, so we have 0 minus 9 over 4. Okay, then we simplify. What is 0 plus 9 over 4? So 0 plus 9 over 4 is just 9 over 4. And 9 over 4 is 2.25. So we can erase this one and rewrite it as 2.25. Okay, this is 2.25. And of course, if it's 0 plus 9 over 4 is 2.25, or simply 9 over 4, Also, in this part here, for the second focus, it is also 2.25. So in reality, if you solve one, you also solve the other. Okay, so it's 25. Okay, how about this? It's minus 9 over 4, so it's negative. Okay, negative 2.25. So we have here negative 2.25 here. And of course, if this is negative here, negative 2.25, negative for the second focus, it is also negative 2.25. Okay, so we will summarize this, and now we can graph. Yay! We're almost done. Okay, so let's summarize. So these are the foci. No, not the foci, but the endpoints of the lateral recta. Okay, so we also need to change, instead of F, we will use L na. L. So we have L1, and this is L2 here. L2. Here, L2, and the other one is L3 and L4. So L1 and L2 is for the first latus rectum. L3 and L4 is for the second latus rectum. Okay, so let's summarize and then graph. Okay, so let's graph. So first we have the center. Okay, so for the center we have 1, 0. So starting from the origin, so we have 1. Count 1 to the right side. Okay, so 1. So we have here, then 0. So we're not going to move. So since our center is this, so we're not going to move. Okay, so it's just 1, 0. So it's here. Yeah. Okay, so that is our center. I'll just write it as C. Okay, then we have our foci. Okay, so for the foci, so we have, I changed the color to, I just changed the color to blue. Okay, so we have 3.65. So we have 1, 2, 3. So this is 3. Here, this is 3, but 3.65 is 1 greater than 1/2. So it is somewhere here. Okay, somewhere here. F1 is somewhere. I'll just write F1 here. Okay, sorry. I can't write properly. Yeah, F1. Okay, how about F2? So it's negative 1.65. So we have 1 here. Okay, 1 here. 1.65 is greater than 1/2, so it's somewhere here. Okay, so by the way, there is no movement in the vertical axis because the vertical part is 0. So this is F2. Okay, F2. Okay, then what else? We have, okay, so we're done. So later na lang ang length of the major axis. Let's focus on the vertices. Okay, focus on the vertices. So the vertices, we have 5, 0. Okay, so I'll just make it green again. Okay, so 5. Count 5 for the horizontal part. So 1, 2, 3, 4, 5. Then do not move because vertically, don't move vertically because it's 0. So it's somewhere here. It's just here. Sorry. Yeah. So this is our V1. And for our V2, we have negative 3, 0. So count again. So 1, 2, 3. Yeah, negative 3. Then 0, do not move vertically. So this is V2. Okay, so we're done with the vertices. Then we have the co-vertices. Okay, so co-vertices, it's 1. Okay, so there is 1. So here, let's move here 1. So count 1. 1 from starting from the origin, then 1. Okay, then 3, 1, 3. Okay, so again, it's 1, 3. It's here, 1, 3. So 1, then 3. So 1, 2, 3. So it's somewhere here. Okay, so this is our V3. And V4, it's 1, negative 3. So 1, for the horizontal part and for the vertical part. So relative 3. So 1, 2, 3 going downwards. So we have P4. Okay, so we have already the what do we call this? The endpoints or the extreme points, of the ellipse. Then we have the directrices. Okay, so the directrices are always lines. Okay, so this is so what does it mean? So this means they are lines passing through the value of x, because again it's x. The x of 1 is equal to 7.5. So 7.5 is somewhere here. So 1, 2, 3, 4, 5, 6, 7. So it's somewhere here. Let's change colors. Para lang. So it's somewhere here. 1, 2, 3, 4, 5, 6, 7. So here. Okay, so it's somewhere here. But it's a line passing through x, because it's x. So we're going to create a line passing through this point here. So there. Okay, so that is our directrix, or D1 or X1. Okay, so let's just write X1. I just type here X1 equals 7.05. Okay, so why did I write the entire number or the entire expression? This is not expression, entire statement. Okay, it's because it's an equation. So if it's an equation, write everything. Okay, so for the second one, we have negative 5.05. So 1, 2, 3, 4, 5. Okay, so it's somewhere here. Okay, so let's try to draw. Okay, so this is again x sub 2 equals negative 5.05. Okay, so we have now the directrices. Okay, sorry, it's 7.05. Okay, so just imagine us. I'll move a little, so it's not actually there, not exactly there. Okay, it's kind of move a little bit farther than the number 5 and 7. Let's try to fix this first. Okay, here. Okay, so it's somewhere here. So it's kind of offset by a little bit. So somewhere here, and this one is, how is it? 1, 2, 3, 4, 5. I forgot it's 0.5, may 0.05 pala. Okay. So it's offset a little bit. Okay, so then let's try to make a line. Okay, there. Okay, then this one here, there. Okay, so we're done with the directrices. Yes. And we have the endpoints of the lateral recta. So if we're done with the lateral recta, we can actually create the ellipse. Okay, so where is it? 3.65 and 2.25. So 3.65 here. So 1, 2, 3.65. So it's here. So again, it's just actually in line with the focus. Okay, so then let's just count for 2.25. So 1, 2, and 2.25 is somewhere here. Okay, so somewhere there. That is our L1. Or L2. So it's still here, but it's negative 2.25. So 1, 2, 2.25 is somewhere also here. Okay, so this is L2. Then we have L3. Negative 1.65. So it's again aligned with the focus. So here, this is the focus. Then this is also aligned here. Okay, so this is L3, and here aligned also here. Okay, there. And there. Yes. Okay. Hence, we can now draw the ellipse. Actually, we can now draw the ellipse. Let's use black. Okay, so we just need to connect the L. Okay, the L1, L3, L4, L2, L4, L3. Then we also need to connect the V's. So V and L's. Okay, so here. I'll connect it here. Okay, then connect it here. Okay, so take note that it's a curve. So as much as possible, the rough sketch will be curved. Okay, curve here, then curve here, then curve here. Okay, then kind of curved here, and we have here, and lastly it's here. And hence, we have now the rough sketch of the ellipse. Okay, so in the next example, I'll be teaching you another method of sketching an ellipse. So this method is actually the longer method because we have to solve for all of the elements. Okay, so before we graph. For the next example, we're doing the opposite. Okay, what if we graph first before we get the elements? Okay, so see you in the next video. Bye bye.